So this is a continuation of our discussion on the systems engineering lifecycle model, and as we discussed on the previous video, there are three major stages which are shown in this slide. So the three major stages are the concept development, the engineering development, and the post-development. So in the last video we went through the discussion of what is expected in each one of these three stages. So I'm going to skip through the details, and we also had an opportunity to work on this problem in which you needed to complete the lab in class to discuss a minimum of 5 events actions that will occur during each stage of the systems engineering lifecycle model. So in this video, this is a continuation of the lecture on the system lifecycle. Now we are going to go and discuss the activities that are performed in each one of the stages of the system lifecycle model. And we are going to start with the concept development stage. Okay, so the concept development stage has 3 phases, and they are shown here in this diagram. Those are the need analysis, the concept exploration, and the concept definition. And as you can see in this diagram, each one of these phases has a list of activities that are going to serve as inputs and outputs for the next activity within the same stage, in this case the concept development stage. So in the need analysis phase, we are looking at system studies, technological assessment, and operational analysis. What we are trying to do here is to understand the need for the system, like you understand the problem. You're trying to perform studies in understanding what was missing in terms of the solution for a problem. Also, you can start thinking about the requirements for this system. What are the performance that the system has to achieve, and analyze those operational attributes that the system must have. And once you have identified those functions that needs to be performed and what are the performance expected performance, then you can think about the technology that will be needed to build such a system. Then from there we transition. We know the system capabilities, we know the operational effectiveness, the performance. At that point we can start looking at the concept exploration. We analyze the requirements, making sure that this concept will be capable of satisfying the requirements that we develop in the need analysis. And we start synthesizing a concept, trying to elaborate the concept and making sure that it's feasible. And we can come up with a list of candidates to go to the concept definition, in which we analyze the alternatives, the functional architecture, and the physical architecture of the system. So in the needs analysis phase, we define the need for a new system. It addresses the questions: is there a valid need for the new system? Is there a practical approach to satisfying such a need? The output of this phase is a description of the capabilities and operational effectiveness needed in the new system. In the concept exploration phase, now we examine potential system concepts. So now you have an idea of, okay, these are for example, if you're looking at a new design for a car or for a cell phone, we can come up with multiple concepts. One of them might have a better camera, and the other one could have a larger screen, the other one, but in general the system, it's the same. The only thing that you're changing maybe is 1 or 2 subsystems within it. So you have multiple concepts to evaluate the the new system, or the new cell phone in this case, that is going to go to production. And you can ask some questions such as, what is the performance required for this new system? Are we looking for a new cell phone with a better camera, or with more space to store, and so on? Is there at least one feasible approach to achieve such a performance, and in a way that we can do it with the budget that we have, an affordable cost? The output of this phase includes our first official set of requirements, typically known as the system performance requirements. So these are the things that we need to make sure that the concept will perform based on these requirements. In addition to an initial set of requirements, this phase produces a set of candidate system concepts. So performance requirements, going back to the example on the cell phone, we might need a cell phone that has a battery that lasts 1 hour or 10 hours, right? So that's a performance requirement. We might need a cell phone that has a screen at least this size. That's another requirement. We might need certain dimensions to be satisfied, like or we must have at least or a minimum of number of buttons in the cell phone, and so on. Concept definition phase. Here we select the preferred concept. It addresses the questions: what are the key characteristics of a system concept that will achieve the most beneficial balance between capability, operational, and cost? The output of this phase is two perspectives on the same system: a set of functional specifications that describe what the system must do and how well, and a selected system concept. Okay, so from the concept development stage, we move to the engineering development stage. And this one also has three phases, which are the advanced development, engineering design, and integration and evaluation. And as we did for the first stage, we have a diagram that shows the phases and what is expected within each one of the phases. So the advanced development phase, which is the first one for the engineering development stage, has two primary purposes. First, the identification and reduction of development risk. And two, the development of system design specifications. This phase is especially important when the system concept involves advanced technology not previously used in a similar application. So we have seen in class multiple cases in which when you develop new technology, if you are not aware of putting those into tests in different environments, then things can go wrong, especially for advanced technology that have not been used. So systems engineering is central to the decision of what needs to be validated and how, and to the interpretation of the results. So what needs to be validated? If we are going to be proposing a new part, validated in the sense that it's going to perform in all the environments where you need it to perform, and so on. Then we have the engineering design phase. Here's the detailed engineering design of the system is performed in this phase. The systems engineer is responsible for ensuring that the engineering design of the individual components faithfully implements the functional and compatibility requirements. So we need to make sure that this thing is doing what it's supposed to do. The task of this phase deals with converting the component specifications into a set of component designs. And then finally, we have the integration and evaluation phase within the engineering development stage. The output of this phase are twofold. First, the specifications to guide the manufacturing of the system, typically called the system production specifications, sometimes referred as the production baseline. And two, the production system itself. The latter includes everything necessary to manufacture and assemble the system and may include a prototype system. Finally, we get to the last stage, which is the post-development stage. So in this case, we have the production phase. no matter how effectively the system design has been engineered for production, problems will arise during the production process. So for example, a strike at a vendor's plant, unanticipated tooling difficulties, bugs in the software, or an unexpected failure in a factory integration test. Such situations threaten costly disruptions in the production schedule that require prompt and decisive remedial action. Systems engineers are often the only persons qualified to diagnose the source of the problem and to find an effective solution. And then last one is the operation support phase and support phase. Proper planning for the operational phase includes provision of a logistic support system and training program for the operators and maintenance. So this is some of the things that we already discussed. So it's not just putting the system out. You need to provide the environment, the right environment for the system to properly function. So for instance, when the wind turbines came as a technology, as a new technology a few years ago, so the design for the turbines, and they started putting these turbines in the fields. At some point they started having problems in terms of not having enough components for maintenance purposes. So planning for those, the equipment that you need to go and fix a wind turbine, which is usually a very big system. So you might need a crane, you might need a helicopter, and then how are you going to transport all these big parts for such a system? So proper planning for the operational phase is important. These plans should have a major participation from the systems engineering field. There are always unanticipated problems that arise after the system becomes operational that must be recognized and included in the logistic and training system. Very often the instrumentation required for training and maintenance is itself a major component of the system to be delivered. Okay, so that concludes this lecture. Thank you.